Okay, guys. We are on, I think, Wednesday. Okay, and we are in a new note packet. Okay, it's attached on EduFlow. It's packet number 2. We're still in Unit 10, and today we're going to be talking about the Pythagorean theorem. Okay, dealing with radicals. We are going to flip to page 39. Okay, the Pythagorean theorem. And I'm going to you can do all this on your own. Pause the video and then come back. Okay, I'm just going to do this quickly. A squared plus b squared equals c squared. And the Pythagorean theorem is only for right triangles. Okay, list the vocab terms. You probably have things like hypotenuse, and you probably have legs. Okay, and then now make a conjecture regarding how the Pythagorean theorem relates to Unit 10 radicals. Sides may be radicals. Okay, and we're dealing with exact and approximate answers. Okay, so that's what I would say about that. Okay, we're not going to spend a lot of time on that. On to page 40. Again, we're not going to spend a ton of time on this review because that's what it is, review. When you have a right triangle, you can use the Pythagorean theorem to find missing sides. It's a squared plus b squared equals c squared. Okay, where a, b are the legs, and c is the hypotenuse. Okay, when we're talking about a leg, it's two sides of a triangle that form a right angle. Okay, that's what a leg is. And then for the hypotenuse, let's write that over here, hypotenuse. Kind of have two definitions. The first is the longest side of a triangle. Okay, that would be the first definition. The second definition would be the side opposite the right angle. Okay, so here we've got the hypotenuse opposite that right angle, and here we have a leg, and here we have a leg. Okay, and I'm not going to spend a ton of time on the proof for this. You guys should have done that last year with Mr. Robert, but basically, if you have a square, okay, the area is going to equal a times a, which is a squared. Here, if every side, because it's a square, is the same, your area is going to equal your b squared. And here, if every side is c, because it's a square and they're all the same, your area is going to equal c squared. Okay, so a squared plus b squared equals c squared. Okay, let's go ahead and go to page 41. Moving right along. Here, this part is just a review. The legs of a triangle are 3 meters and 4 meters. What is the length of the missing side? We've got a squared plus b squared equals c squared. So we're doing 3 squared plus 4 squared equals c squared. It's going to be 9 plus 16. We got c squared equals, 25. Take the square root, and we're talking about side length, so we're also only dealing with the positive side. And that's going to be c equals 5, meters. Okay. Remember, no negative side lengths, and you can actually, and some of you may remember this from last year, I think Mr. Robert talked about this, Pythagorean triple, okay, which is 3, 4, 5. So some students like to memorize those and you can just see that right away. Some of you want to show the work, and that's okay as well. Going over to B, the leg of a right triangle is 12 feet, and the hypotenuse is 15. What is the length of the missing side? Well, here we have a squared plus b squared equals c squared. So we've got, let's see, what do we have here? We have, sorry, I lost my train of thought here. We have a squared plus 12 squared equals 15 squared. Okay, so we're going to have a squared plus 144 equals 225. We're going to subtract 144. We're going to get, 81, I think. Take the square root, and that's a equals 9, and that is feet. And some of you might recognize the Pythagorean triple. Again, we have 3, 4, 5. If you take everything times 3, you're going to get 9. You're going to get 12, and you're going to get what? 15. So that's actually a Pythagorean triple as well. But if you don't see that, it's okay to do the work, okay? And then let's go down to D. The leg of a right triangle is 7 feet, and the hypotenuse is 25 feet, what is the length of the missing side? Okay, we're going to do 7 squared plus b squared equals 25 squared. We've got 49 plus b squared equals what? 625. Subtract 49. We get b squared equals 576 over there. Nice perfect square. We've got b equals 24 feet. And again, you may not recognize that, but for those of you who do, it's a Pythagorean triple again. It's 7, 24, 25. Again, don't have to memorize those. It's okay to just show the work. Okay, let's go ahead and go on to page 42, moving right along. Here you can see the Pythagorean triples. Again, I think you did this with Mr. Robert last year. A lot of students just memorize the first 6 or so. It makes it easier for you and you don't have to show your work. That's totally good to do, but again, you don't have to. What does it mean if the Pythagorean theorem doesn't work? Example 349. 3 squared plus 4 squared equals 9 squared. That's 9 plus 16 equals 81. Well, 25 obviously does not equal 81. Okay, and that's a way to show that it is not a right triangle. And that's the converse of the, oopsie, let's ran out of room here. Converse of the Pythagorean theorem. Okay, and we can say if a squared plus b squared does not equal c squared, then triangle is not right triangle. Okay, so you're going to do problems like that where you have to prove whether or not it is in fact a right triangle. Okay, let's look at B. The legs of a right triangle are 10 meters and 12 meters respectively. What is the length of the missing side? Okay, it says the legs. So we're looking for, again, I'm just going to write the formula. You can never write it too many times. We've got 10 squared plus 12 squared equals c squared. Okay, that's going to give me 100 plus 144. Okay, c squared equals 244, and this is where it gets kind of fun, okay, because we're going to take the square root and it's not a perfect square. So we're going to go ahead, we're going to look, if I can find my calculator here. I did have it, and now I've lost it. Let's see what I can do here. Oh, I found it. It's behind my computer hiding. Okay, so I think I always look if it's an even number to see if it can be divided by 4 first. So we can divide by 4 because we know 4 is a perfect square, and it is 4 and 61. So I'm going to say c squared, c equals 4 times 61. So you got c equals 2 root 61, and that's meters. So for these kinds of problems, when we're dealing with radicals, you need to put an exact and an approximate, okay? I'm a stickler about that. You need to have both. So c equals 2 root 61 meters, and c equals approximately, I'm just going to put in the square root of 244 because that's what it was originally. We get 15.62. 15.62 meters. And there you have it. Okay? Moving on to page 43. We're going to just do one down here. I want to look at letter F. Okay? Again, we're on page 43. The legs of a right triangle are root 3 and 2 root 4. And the hypotenuse is x. What is the length of the missing side? Well, we've got root 3 squared. A squared plus b squared equals c squared. Plus 2 root 4 squared equals, and it said x squared, called it x or c. Well, root 3 squared is 3. 2 root 4 is going to be 4 times 4, right? Because that becomes 4 and that becomes 4. So we've got 3 plus 16 equals x squared. X squared equals 19. I'm going to take the square root, and there's no perfect square inside of 19, so x equals root 19, and that's my exact. We're talking about, does it say? Centimeters. So there's centimeters. And my approx, if I put that in my calculator, 19 is going to give me 4.36. So 4.36 centimeters. Okay? Hopefully this is all review. We're just throwing in radicals now. We're going to move on to page 44. Okay, and example 3. Determine whether the triangle with the given side lengths form a right triangle. Okay, this is that converse theorem. Show your work in the space. So we've got, I'm going to do B, 9, 24, 21. Now remember, the longest side is always the hypotenuse. Okay, so we're going to do 9 squared plus 21 squared equals 24 squared. That's 81 plus 441 equals 576. 81 plus 441, if you want to put that in your calculator or do it on the side, I know it's 522. Quite obviously does not equal 576. So we can say, in conclusion, not a right triangle. Okay? Let's look at this one here. We've got 24 squared. Again, longest side is the hypotenuse, plus 143 squared equals 145 squared. Okay, I can actually see that that's a Pythagorean triple. And if you do see that and you want to look back at, wherever our sheet was that listed the Pythagorean triples, okay, you've got 24, 143, 145. So if you ever want to use your chart when you're doing your homework, you can just say Pythagorean triple. So it is a right triangle. Or if you want to show the work, that's fine as well. Okay? Moving on. We're moving right along here. We're at example 4. Okay? This is a really good problem. A right triangle has one leg that is 3 times as long as the other leg. 3 times as long. Okay? So if we make the first leg x, the second one is 3 times that. So that's 3x. Okay? And the length of the hypotenuse is the square root of 40, okay? And it wants us to solve for x. Well, we can use the Pythagorean theorem, x squared plus 3x squared equals root 40 squared. Okay, we get x squared plus 9x squared equals 40. Okay, I'm gonna move, let's see, I've got, not gonna move anything. I can combine some like terms there, can't I? Divide by 10. You get x squared equals 4. Oh, how nice is that? X equals 2. And again, only positives because we're dealing with side lengths. So if one side is 2 inches and it says the other is 3 times as long, we're going to take 3 times 2 to get 6 inches. And there are our sides, okay? 2 inches, 6 inches, and then root 40. Okay. Let's go to 45. Page 45, I should say. Let's do, sorry, I'm just organizing here. Letter B looks like the same problem almost. A right triangle has one leg that is 4 inches shorter than the other. 4 inches longer. I can't read today. So we've got one leg that's x, and we've got the other leg that's 4 inches longer. So it's not times, it's just plus. It's 4 inches longer, and the hypotenuse is root 106. Okay, so to solve, we're going to use the Pythagorean theorem. And we get x squared plus, and again, x plus 4, we're going to put it over here so you guys can see. That is FOIL. You've got to do x plus 4 times x plus 4. We get x squared plus 8x plus 16. So I've got plus x squared plus 8x plus 16 equals 106. Combine some like terms here. Okay, I'm going to, look at that. Those are all evens. Let's go ahead and divide out the 2. Make your lives easier. We're going to do x squared plus 4x plus 8 equals 53. Okay. Kind of a lengthy problem here. I'm going to subtract 53 from both sides. I get x squared plus 4x. What is that? Minus 45. And I hope you see 9 and 5, a positive 9 and a positive 9, negative 5. To factor that, x plus 9, x minus 5 equals 0. Now, we can't have a negative side, and that's going to end up with negative 9. So I would just go ahead, cross that off, and say extraneous. And so your answer is going to be x equals 5 inches. Okay? And it said the other one is 4 inches longer, so 5 plus 4 is 9. So we also have 9 inches, and 5 inches are our 2 side lengths. Okay? Let's see. I'm looking through this. Let's go to, we're going to go to our special cases now. I want you to go, and we're going to skip over all the way. Move this out of the way. Let's skip over to page 47, okay? Let me write that at the top. Now, these next 2 pages are super important. We're going to be talking about some special cases, okay? Special triangles, okay? The first special case is going to be a 45, 45, 90 degree triangle. And what I mean by that is that those are your 3 angles. If you have 45 plus 45, that's 90. So what's left is 90, okay? Let's first show the math. We've got 5 squared plus 5 squared equals x squared, okay? 25 plus 25 equals x squared. X squared equals 50. We're going to take the square root of both of those. What is that? 25 times 2? So we get x equals 5 root 2, okay? So that's my missing side, 5 root 2. Now, let's talk about, or let's do one more, and you guys will be able to see the pattern, I think. Each of the legs of a right triangle are 6 inches in length. What is the length of the hypotenuse, okay? So that's a 6 squared plus 6 squared equals, we'll say c squared. That's 36 plus 36 equals c squared. C squared equals 72. Square root it. That's what? 36 times 2? So that's going to be c equals 6 root 2. And I hope you're starting to see the pattern, okay? What happens is that when we have a 45, 45, 90 degree triangle, the two sides or the two legs are going to be the same, and the hypotenuse is that side length times square root of 2, okay? So if you look over at this one, we have a 45, 90, so this must be 45 degrees, okay, because they add up to 180. We have a side length that's 11, it's a 45, 45, 90, so we automatically know that that is 11. And we said that the hypotenuse is always the side, and they're both the same, so it's 11 root 2. Always, always, always. If you look at D, we've got 8 feet X and Y. And so that's actually a little tricky one. Why don't you guys try this on your own and see if you can do it? Okay? That's a really good problem. Okay, let's move on. So that was our special triangle. So that was, let's just take a little note down here. That's our 45, 45, 90. And those two are going to be the same, opposites. Opposite side of 45 and 45 are the same. And that's going to be the number root 2 is that, okay? Let's go on to page 48. We are in the home stretch. We're almost done here. Okay, we've got our second special triangle, okay? And this is a 30, 60, 90 triangle, okay? And so we're going to do 5 squared plus x squared equals 10 squared. Okay, we've got 25 plus x squared equals 100. We've got x squared equals 75. Square root, x equals 25 times 3. So we get x equals 5 root 3. Okay, so that's this right here. Okay, and I'm just going to tell you what the pattern is. Okay, so you've got a side opposite 30. That's going to be whatever your side length is. Okay, your hypotenuse is double that. Okay, it's double that. And then your other leg opposite the 60 is your side opposite your 30 times root 3. I know that's confusing, but that's how you do it. So if we were to look at this one, we have a 3. The hypotenuse is double 3, which is 6. And then this is going to be 3 root 3. And if you want to prove it, you can. 3 squared plus x squared equals 6 squared. Subtract 9 from both sides. We get x squared equals, what is that, 27. We get x equals 9 times 3, which is x equals 3 root 3, and that's units. Okay, so I proved it. I could already do it, right? If we do this one, let's just look at this. I was going to have you do it on your own, but just let's look at it. So the side opposite 30 is 14. Okay, the hypotenuse is double that, so that's going to be 28. 2 times 14 is 28. The y, which is opposite the 60, is the 14, and it's always root 3. Okay, so that's how you do those types of problems. I know that was quick. Slow it down as you're watching it if you need to. I do want to do one more problem that I think is super important, and that is going to be on page 57, and I promise this is the last one. Okay, we're going to look at 25C because I think this is a really great problem. Find the value of x so that the given set of values forms a Pythagorean triple. Show your work in the space below. Okay, well, they're just talking about the Pythagorean theorem here. Okay, so we're going to do x minus 2 over 2 squared plus x squared equals x plus 1 squared, okay? We just want to turn it into the Pythagorean theorem. That's how we're going to prove or find the x value so that it's a Pythagorean triple, so that it is a right triangle, in fact, okay? This one's messy. We're going to FOIL out the top. That's x squared minus 4x plus 4 over 4, so we have to square the top and bottom, plus x squared equals, we're going to FOIL that out, x squared plus 2x plus 1. Now bear with me here, okay? I'm going to divide each of these up. And when I mean by divide, I'm going to put it over each one. So I have 1/4 x squared, because that's just x squared over 4, same thing, minus, that cancels, so minus x, plus 1, plus x squared equals x squared plus 2x plus 1, okay? I can see here that I have an x squared and a 1/4 x squared. That's going to give me 1 1/4, or 1.25 x squared. I have a minus x here, a plus 1 here, x squared plus 2x plus 1. Okay, I'm going to go ahead and what am I going to do? Let's subtract the x squared from both sides. Okay, I get 0.25 x squared minus x plus 1 equals 2x plus 1. I know this is super tricky. Okay, let's subtract 2x from both sides. I'm moving everything over. I get 0.25 x squared minus 3x plus 1 equals 1. Subtract 1 from both sides, and I get 0.25 x squared minus 3x equals 0. Now, I don't know about you, but I definitely do not want to deal with a decimal. So if you think about it, what can you multiply 0.25 by to get it to be a whole number? And that would be 4. And if you do it to 1, you have to do it to everything. That's going to give me a 1x squared, or x squared. That's going to give me minus 12x, and that stays 0. Now you can see that you can factor out an x, and x equals 0, or x equals 12. That's extraneous. So my answer is x equals 12. Whew, I think 25D is a homework problem. Use this as your example when you're trying to do it, okay? And I think we're at the 22-minute mark, and I think that is plenty for today, okay?